Okay, this is page 4, number 4. So what we have is we have Quinn running around a track with the equation x squared plus y squared equals 10,000. It gives us a radius. What's the center of this track on the coordinate plane? 0, 0. And Quinn's running at 4 meters per second. So let's go ahead and sketch this. See my great circle art here. So we have our circle. The radius is 100, so I know this point out here is 100, comma 0. And Quinn is going to run counterclockwise. All right, so Quinn's going counterclockwise here at 4 meters per second. And Quinn's going for 30 minutes. So what's the first thing we want to find here? How far Quinn goes. So we can figure out how far Quinn goes total, taking 30 minutes. And Quinn is going 4 meters per second. So if we take 4 meters per second, well, how many seconds is 30 minutes? So it's 1,800 seconds and 4 meters per second. So 1,800 times 4. And that gives us 7,200 meters. Okay, so now we know how far Quinn runs. Now what do we have to do? Find the circumference of the track. So the circumference is pi times diameter, or 2 pi r, so 2 radius. So the diameter is what? 200. So I'll just go 200 pi. That's the circumference of the circle. 200 pi meters. Okay, so now I have the circumference, so what's the next idea here? So we have how far Quinn ran, and we have the circumference of the circle. Divide, and why would you divide it? Yeah, how many times they ran around the track. So this is going to give us how many times Quinn ran around the track. Do a little calculator work here. We can just plug that right in the calculator with a 200 pi. Okay. Double check me if I'm wrong. I got 113.097. Okay, so that 113 did not look right. And we should have put parentheses around my calculator. That was my mistake there. And it gives a point about making sure that your calculator, that you plug it in correctly. So, can I erase that? No. So, redid it with correct parentheses, and I got 11.46. That sounds better. I figured that jogging 113 times around the track would be a lot. So now we know that Quinn went 11.46 times around the track. So we can imagine Quinn starting here. There's 1 time, 2 times, 3 times, 4 times. They keep on going until they get 11. And then 0.46 would probably bring Quinn, which quadrant would Quinn be in after 0.46 times? Quadrant 1, so it would be in this quadrant right here? No. 2. Yeah, because this would be half, 0.5 would be half. So around here somewhere. So let's go ahead and make a point. Just a guesstimation here for 0.46. Okay, so now we know that we want to know the coordinates of that point. That is a not straight line. But we want to get the idea of what that coordinate point right there is. And what we've been learning lately is that to find that coordinate point, we need the angle right here. Okay, we need that angle. So, how am I going to find that angle knowing that that is 0.46 times around the track? Right, so we go 360 times 0.46. $165.6. And that makes sense, right? Because 180 would be all the way to the negative x axis. So that's 165.6 degrees. Okay, and now actually we worked on it yesterday, but does anybody remember how we're going to find that actual point? Tom, do you have a question? Right. So to find this actual point, and I'm going to change colors here. Maybe I won't change colors. There we go. Okay, so to get that point, we can do r cosine theta, r sine theta. That will give us our point. So definitely something you need in your notes, know how to do. And from that point, we can just substitute in our r. What's our radius again? 100. So 100 cosine 165.6, comma 100 sine 165.6. And let's do some calculator work here. Okay, so after our calculator work, we got a negative 96.86, which makes sense because all the way to that intersection point there would be 100, a little bit shy of that. And then we have a 24.87 for the y-coordinate. It looks like it's up about a quarter because it's 100 to the top. Questions there?